Hi, this is Jeff with a little number combinations problem for you, a trick problem with how many possible numbers can we have with certain constraints on our digits. And if you enjoy this video, if you find it helpful, please share it. Check out my blog, roomtodiscover.com, sign up for my mailing list, or sign up for my upcoming course on using visual models in elementary math. Okay, I want to thank Omar Ashraf for submitting this question. The task is to use the digits 1, 2, 3, and 5 and to figure out how many four-digit numbers can be formed. So this is a combinations type of problem, and combinations are a type of multiplication because we are looking at how many options we get, and so we multiply by the number of possibilities. So let's take a look. So for the first one, the first digit must be 1, and repetition of the digits is allowed. So here we have a constraint. The first digit must be 1. So as you can see in this table I drew beneath, all the first digits are 1. Now our options are in the second digit, which I've gone across the x-axis, and the third digit. Now you notice I don't have an option for the fourth digit because that would actually, this should really be a three-dimensional table or three-dimensional array, but it's really hard to represent that on a two-dimensional surface or document. So I've made this table is where the fourth digit is 1 for every problem, and I've gone, so if we know our first digit's 1, our second digit is 1, then our third digit is 1, and for every item in this table, the fourth digit is 1. So this shows 4 times 4, and the problem is asking us, since the first digit must be 1, we only have one option for the first digit, so it's going to be 1, and then we have 4 options for the second digit, and we have 4 options for the third digit. So this table is showing me the 16 options that I can get with only 3 digits. Now to do a fourth digit, since I can't actually make it in 3 dimensions, all I would need to do is copy this table, right? So if I make a copy of this table and put it underneath, and for this version, table 2, the fourth digit is always 2, and then I would just go through all of these and change it so that the fourth digit is 2, and obviously I would have to do this 4 times because we have 4 possibilities. I'm not going to do that because I think this is enough to illustrate that, but I would have 4 tables, and then so that's why I would multiply again by 4, and I would get 64 for question A. Now for question B, the first digit must be 1 and repetition of the digits is not allowed. So now what we're doing is, let's say I still constrain my first digit as 1, right? And my second digit is 1, but I'm going to eliminate this option, right? So if my second digit is 1, my third digit can't be 1. And in fact, since the fourth digit is 1, I can eliminate this entire row because I can't repeat my digits. And actually, I can eliminate this entire table because I can't have my first digit be 1 and my second digit be 1. So, see ya. Okay, that table is completely gone. Now, if my fourth digit is 2, my second digit still can't be 1 because my first digit is 1. So I can't repeat digits. So I get rid of this entire column. Fourth digit is 2, my second digit can't be 2, so I get rid of this one as well. Second digit is 3, but my third digit can't be 1 because that's a repeat. My third digit can't be 2 because my fourth digit's 2, so that's gone. Third digit is 3, nope. Oh, now finally we have one that has 4 different digits, so this one is a valid combination. So third digit is 1, that's gone because my first digit is 1. Third digit is 2. No, because my fourth digit is 2, so that has to go. 1, 5, 3, 2, third digit, so that's valid. but then here I can't have my second digit 5 and my third digit 5. So as you can see, we're drastically cutting down on our possibilities here. What actually happens is, so if my first digit is 1, I have one option, right? Now, instead of 4 options for my next digit, I only have 3 because I've eliminated 1, right? So now I only have 3 options for my third digit. Now I only have 2 options. Sorry, I have 3 options for my second digits. I have 2 options for my third digit. Then I'm only left with 1 option for my fifth digit, because what I'm doing is I'm eliminating 1 as I go on. So my total here should only be 6 options. Let's check that. So 1, 2, 3, 5. So that's, and yeah, so that's the only, I can only have one option where 2 is in my second, or no, I can do 1, 2, 5, 3. I can do 1, 3, 2, 5, 1, 3, 5, 2, 1, 5, 2, 3, 1, 5, 3, 2. 1, 2, 3, 4, 5, 6. These are all the combinations where I'm not repeating digits. Now, if the number must be divisible by 2 and repetition is allowed, well, we're going to go back to our original where we had 64 options, but we're going to eliminate all our odd numbers. So for a number to be divisible by 2, the last digit would have to be even, right? So the last digit can't be 3 or 5. So I'm going to cut that in half, right? So if I have, I'm sorry, we're not constraining the first digit anymore. So what we're going to do, since we're not constraining the first digit, is we have 4 options for our first digit. We can repeat, so we still have 4 options for our second and our third digit. Our fourth digit, though, instead of 4 options, 1, 2, 3, and 5, we only have 1 option, 2, because 1, 3, and 5 are all odd. That's probably why they didn't put 4 in there, to make this one a little more challenging. So we actually still have the same. We have 64 options, and I'm not going to go through drawing all those charts again because I think it's been illustrated, but if anybody wants to take this one on, I think that would be a cool challenge to actually use the charts, or somebody else mentioned trees as a way to put that in there. That could be cool as well. And then the number must be divisible by 2 and repetition is not allowed, but we're not constraining our first digit. So what we're going to do is we're going to have 4 options for our first digit, then there's 3 left after that, then there's 2 left after that, and there's 1 left after that. Oh, and it must be divisible by 2. So we're going to do, this will give us, if there's no repetition, 4 times 3 times 2 times 1, 4, 12, 24, and then it looks like we're going to actually have to divide that by 4. Again, we should end up with 6, and let's check that. 1, 2, 3, 5, 1, 2, 5, 3, 1, 3, 2, 5, 1, 3, 5, 2. Right, so this as a sample, these are our options where we have 1 in the first digit, but only one of these ends in 2. If we have 2, this is actually really interesting, because then if we have 2 in the first digit, one, 5, 2, 3, 1, 5, 3, 2. Okay, so we have 1, 2, 3, 4, 5, 6 options. 2 of them are divisible by 2. It must be divisible by 2, and repetition is not allowed. Here, so we're going to get the same number for each starting value, but the interesting thing is that when 2 is the first digit, none of them are going to be divisible by 2. So all of these get rejected. So we're going to get 2 when the first digit is 1, none when the first digit is 2, and then this is gonna repeat. We're gonna get 2 when the first digit is 3, and 2 when the first digit is 5. So the last one is going to give us 6 combinations. And again, I did a quick version of this, but you could also do a more explicit version using the tables, and if anybody wants to do that and send it to me, that would be awesome. So hopefully this helps with that task.